All right, complex numbers. Complex number is the imaginary number system. And that comes from this definition that the square root of -1 is defined to be I. Okay, so that's the major premise that gets us into the complex number system. The complex number system exists because there are some quadratics that we'll try to solve that don't have real number solutions to them, meaning that they have answers, but they don't show up on a regular coordinate plane. If we were to graph that quadratic and all that, they don't show up like the others do. So that's the complex number system. And I usually, may hear somebody call it an imaginary number. Just a bad way of naming it. But that's the way they named it when they first started discovering it, that they existed. They didn't know what else to call them. They said, we know these answers exist, but we can't find them. So they called them imaginary, and the name stuck, unfortunately. So main thing you got to know, if there's a negative under the square root, you can always pull an I out. If nothing else simplifies, an I always will come out if it's negative underneath there. So let's look at some examples of simplifying, which is the same thing we did yesterday. The only difference is the number inside is negative. So we got a square root of a -36. What's the square root of 36? But because it's negative, it's 6I. That really is the only thing that changes on this part. If you had a square root of -24, 24 is not a nice square number like 36 was. So we're going to have to break it down using factor trees like we did yesterday, or whatever method that you were using. It should be a lowercase I. Yes, it does matter. All right, and so 24 would be 8 and 3, 4 and 2. There's a pair of 2s. So a 2 is going to come out. Because it's a -24, an I also will come out with that 2 and leave 6 inside of the radical, or inside of the square root. The I goes right in front of the radical. It's where it's going to go. Like if there's a number that comes out, put it first, and the I should be just like right up against the radical there. That's the normal way of writing that. Okay. We'll look at some complex numbers and do some operations with them in just a minute. But square root of -48. So a lot of the same stuff we did yesterday. I think we probably did some of these same numbers yesterday, or not yesterday, before yesterday. So we got a negative inside of there. I got a question. Because the negative inside of the radical. It's the whole reason the I even comes out. So here we got a negative. So we know an I is going to come out. Then we think 48. That's not a square number. So I know something's going to be left over. So let's find out what's left over. You do 16 and 3, 4 and 4, 2, 2, 2, 2. I would probably stop at the 4, 4 because it's 4I radical 3, or square root of 3. All right. So a negative underneath the square root, you're going to be able to at least pull an I out of it. And then you simplify the number the same way we did the last couple of days. Okay, so nothing has changed as far as that goes. Let's do one more of those. Let's say we had something a little larger, like square root of -120. Somewhat large. 12 and 10, 6 and 2, 3 and 2, 5 and 2. So I got a pair of 2s, and then no other pairs. So what's on the outside? 2I square root of how much? 30. Yeah, I thought I heard somebody say 30. So other than the I, it's not any different to simplify a square root than it was the last couple of days. It's the same thing. Okay. Fairly simple as far as that goes. Now, let's talk about operations. Three times 5 times 2. Operations with complex numbers. All right. Operations with complex numbers means like add, subtract, multiply, divide. That's what I'm talking about. A complex number has a standard form of a plus b I. So there's the way it's considered is this a is the real part, the b I is the imaginary part. Together, it's a complex number. So it has this standard way of writing it. You put the plain number in front, plus or minus the imaginary part. Okay, so we're going to talk about how to add and subtract these. I'm going to show you how to do it by hand, and then I'll show you your graphing calculator can handle adding, subtracting, multiplying complex numbers. It cannot simplify negative square roots, though. It just can't do it. It's too much for it to intake. But it can do some operations with the I. So let's look at the first operation. Here's a complex number, 8 plus 2i, plus another complex number. Let's say it's 10 minus 3i. Complex number plus another complex number. It's just like adding and subtracting polynomials. You put the like terms together. Okay? So 8 goes with what? 10, because they're just plain numbers. So 8 plus 10 would be 18. And then positive 2i plus a negative 3i would be negative 1i or negative I. And you've added two complex numbers. Not very complicated at all. Very easy. If you subtract two complex numbers, negative 6 plus 4i minus 5 minus 8i. Same idea, like terms. Negative 6 minus 5 would be what? Negative 11. And then 4i positive minus a negative 8i. Positive 12i. And we've got that there. I'll show you how you can check that stuff with your calculator, because it'll do that stuff. I don't usually do addition and subtraction with the calculator, just because it's too easy to just, it's just two things. It's not much to it. So, but I want to show you that your calculator can handle that. So on the regular calculator screen, if you wanted to type in those two let's do example E again, where you had 8 plus 2i. To get the I on your calculator, you got to hit the second button, which is the blue one, and then the decimal point. If you look above the decimal point, there's a little blue I there. That's 2i. So second decimal point. Whoops, I didn't get the second button. Second decimal point. And then close parentheses plus, and then I'm opening up another set of parentheses and doing 10 minus 3i. Minus 3. And to get the I again, it's second decimal point. And what do you know? It's the same answer we got. So you can type it in that way. And it works out really nice for you. And you could do example F the same way, using that subtraction. And I usually do the parentheses as a safeguard that way if signs change or something like that, especially with subtraction, the parentheses are important. All right. Now, let's look at maybe a little bit more difficult one in this operation. And let's do like 2/3 plus 7i plus 1/5 minus 2i. And this might be one where you actually would use the calculator for if you wanted to. I would say we're all intelligent enough to do it without one, but I'm not saying you can't use it. Okay. So if I'm adding 2/3 and 1/5, that's 3/8, right? I hope you say no. because it's not. 2/3 and 1/5, you got to have a common denominator if you're going to do it without a calculator. It'd be 15, wouldn't it? 10/15 and 3/15. So I'm not changing the I parts because they don't need to be changed. So together, then that would be 13/15 plus 5I. In the calculator, if you did that, parentheses, 2/3 plus 7I plus 1/5 minus 2I. Mine is set to not do fractions automatically. Yours may or may not be set to do that. If it comes back with a decimal there, all you got to do is hit math, enter, and it'll throw it into fraction form, which is the way we want it for the most part. Most of the time, that's how we want that. It's in fraction form. Okay, so easily done with or without the calculator, honestly. Now, addition, subtraction, pretty easy. Let's get into multiplication. So when we're multiplying, there's some things we got to remember. Where does I come from? Square root of a -1. Okay? I squared is like squaring the square root of -1. So I squared is actually equal to -1. And then I to the third power is equal to -I. And then the last one we need will be I to the fourth power is equal to +1. That little chart right there, you need to memorize. Yeah, you got to remember that. That's an important thing. Because when we multiply, if we multiply I times I, we're going to get an I squared. And if we multiply, 3 of them together, we might get an I to the third power. If we multiply 4 complex numbers together, we could possibly get an I to the fourth power. But we got to simplify it as much as we can because we want to be able to write our answer in standard form. So let's look at some examples of multiplying. And this is where the calculator can be pretty handy because it can do all the simplifying all in one step for us. I'm going to do it by hand and with the calculator just to show that it can be done that way. Let's say we had something like 5I times 6 minus 7I. What property does that look like? Distributive property. It's not any different. That's what it is. So you're distributing 5I to 6 and 5I to 7I. Okay. So that's 30I minus 35I squared. Simplifying that, I squared turns into what from our chart? -1. So that's really like 30I minus 35 times -1. Okay, so I'm taking this I squared and changing it into -1 because that's what it's equal to. And then I need to rewrite that in standard form. The I part goes last. The imaginary part goes last. So that's going to be positive 35 plus 30I. Now, if I check that with my calculator, which is very legal to do, 5I parentheses 6 minus 7I. $35 plus 30I. Exactly the same answer as what we got by hand without all the work in between. Okay, so that's kind of handy. Let's look at what if we're multiplying two standard form complex numbers like 9 minus 2I times 3 plus 4I. What is that? It's like two factors we're multiplying together. So it's like x plus 4 times x plus 4, something like that. So we're distributing 9 to both of those. So that'd be 27 plus 36i. And then we're distributing negative 2i to both of those. That'd be negative 6i minus 8i squared. And then we want to simplify everything that can be done. So the like terms go together. So we got 36i minus 6i. It's going to be 30i. And then I squared turns into what? Negative 1. So that makes that negative 8 times negative 1, which would be positive 8. So 27 plus 8 would be 35 plus 30i. Has to be the same answer as the other example. I thought that was interesting. That's why I did. Okay. Okay. So here we're converting our I squared to negative 1 and then multiplying that together to turn that to a positive 8. 27 plus 8 is 35. Here in the middle, we got 36i and negative 6i. 36 minus 6 is 30i. If you type that into your calculator just like that, parentheses 9 minus 2i, and then 3 plus 4i, get that same answer. There shouldn't be any reason you miss any of that. Let's look at this kind of problem. Looks innocent enough. That 3 over I. So it's a fraction. But what does that I really represent? The square root of negative 1. So that means it's really a square root that's in the denominator. We need to fix that. How did we rationalize the denominator the last couple of days? Multiplied it by whatever the radical was, the square root was on the bottom. So we're going to multiply the top by I and the bottom by I on this one. We 3i on the top. What on the bottom? I squared, right? But what's I squared? Negative 1. So we have 3i divided by negative 1. What's 3 divided by negative 1? Negative 3. Now on your calculator, if you do 3 divided by I and hit enter, it fixes it like that. Okay, so I'm just showing you that this piece of technology can handle some of this stuff to help you out. Look at this one, a little bit more difficult. 6 plus 2i in the denominator. So that's a lot like number 11 on the quiz today. And if you did that correctly, you multiplied by what? Yeah, 6 minus 2i, the conjugate of that, which is change the sign in the middle. 6 minus 2i on top and on the bottom. So on the top, we get 30 minus 10i. On the bottom, remember the middle, the i's are going to cancel out, the middle pieces. So we got 6 times 6 is 36. And then 6 times negative 2i is negative 12i. And then 2i times 6 is positive 12i. Those are going to cancel each other out. And then positive 2i times negative 2i is negative 4i squared. These two in the middle cancel out. But what does negative 4i squared, what does that turn into? It would be positive 4. So we end up with 36 plus 4 on the bottom. Which would be 40, right? And then Here's where you've got to look at it and say, okay, can I simplify any? 30, 10, and 40, do they have something in common? 10 goes into all of them, so divide them all by 10. You'll get 3 minus I over 4. Or, if you want to write it 3/4 minus 1/4 I. That's the same thing. On the calculator, if you just type in 5 divided by parentheses, and what was it, 6 plus 2I? 6 plus 2I. You got to put the parentheses in there, and then math, enter. There's the standard form of that. That's why I wrote it that way. That's the way the calculator's going to crank it out. So a little easier on that end of it. Okay, so shouldn't be any reason we have trouble getting those right. Now, that doesn't help us much when we go to solve things, but it does help us to operate with complex numbers. Yes, ma'am? All right.
Thank you.
Mm-hmm. All right, so let's look at solving a few. What are we on here? L. Solve. So this is back to solving square root problems, just like we did yesterday. So we got 2x squared plus 11 is equal to negative 37. What do we have to get by itself? Have a good day. The x squared, yeah. So move the 11. 2x squared is equal to negative 49. No, 48, excuse me. And then divide by 2, right? X squared is equal to a negative number, negative 24. Now, yesterday, if that happened, we'd have had to say no solution. But today, we can answer that. I don't think any of them you had in your homework had that problem. But so we're going to take the square root of both sides. Plus or minus is still involved. That doesn't go away. So we think about 24 breaking down. Got a pair of 2's. So it's 2. What else comes out? I radical 6, or square root of 6. And that's the solutions to that one. So the only difference is you're going to have to pull an I out when you simplify your square root. That's the only difference that happens with this particular section. Let's look at M. Let's say we had x minus 3 squared plus 19 is equal to 1. What do we do to that one? Move the 19, yeah. So x minus 3 squared is equal to negative 18. Now what? Take the square roots. Plus or minus on that side. So x minus 3 is equal to plus or minus what? How does this? 3i radical, good job. 3i radical 2. And then we get x by itself. Plus 3. 3 plus or minus 3i square root of 2. So once you get there, when you're solving, it's the same thing we did yesterday and the day before. Just got the I involved in your answer. And that happens because you have a square root of a negative number. All right. So with this, what that allows us to do is solve any quadratic now, no matter if it's got a positive or negative that it's equal to, we can solve it. When we had factoring, it had to be equal to 0, and then the numbers had to be perfect for it to happen, for us to be able to factor it. Solving by square roots yesterday and the day before, it was, we had to have something squared only. Well, when we get to this last section here for today, section 4.7, we need to be able to complete the square to solve one. So what I'm saying is we want to be able to take some polynomial and solve it. Something like this: x squared minus 16x plus 8 is equal to 0. Maybe they give us a problem like that to start off with, and they want us to solve it. And up to this point, we're not allowed to use quadratic formula, even if you know it from Algebra 1. Don't use it. I want to. We'll do that the next thing, and then I don't care which method you use after that. Okay, so want to be able to do completing the square. So for this one, I see it's equal to 0, so that should automatically trigger my head. Try to factor it. Do we know of anything that multiplies to be positive 8 and adds to be negative 16? No, there's nothing that does that. That number in the middle is way too big for that to happen. So what we want to do is complete the square. And when I say complete the square, I want to create a polynomial or a quadratic over here that factors as the same factor twice. And I want to show you how to do that with this one. Okay, so the first thing you want to do is move the constant on the end. So I'm going to move the 8. I'm going to leave that space there because I'm going to need it. Okay, so I'm just bringing this down. X squared minus 16x, and I'm leaving some space is equal to negative 8 over there. All right, now the next thing I want to do, so the first step, that's number 1. Number 2 would be divide. If there's anything in front of x squared, divide by it. There's nothing in front of it this time, so we don't have to do that. Okay. After we've done that, we're going to take 1/2 of b. Okay, so step 1 is subtract. I'm going to write the steps over here on the side. The constant. That's the 8 that we subtracted there. Step 2 would be divide by a. Remember, a is always in front of x squared. Remember that from the standard form of a quadratic. And then the third step is take 1/2 of b and square it. And add to both sides. Okay. Step 2, not needed in this problem. Step 3, that's this one. 1/2 of b. b is this number that's beside the x. What's 1/2 of negative 16? Negative 8. So I'm adding negative 8 squared to both sides. If I do something to this side, I've got to do it to the other side. That's the whole thing with equations. We have to do that. Now, here's where the complete the square gets easy. Once you've done it to this side, the factoring, you don't even have to think about it. That it always will factor as x minus or x plus 1/2 of b. So step 4 is factor as x plus 1/2 of b squared. And then simplify the other side on that same step. So negative 8 squared is how much? 64, and then 64 plus negative 8 would be 56. Now look at this problem. It looks like what we did the last couple of days, right? We can take the square root and get x by, get the x's by themselves. So step 5, solve by square roots. Okay, plus or minus on that side. So we end up with x minus 8 is equal to plus or minus, and that's not a negative number over there. It's positive 56, so it's not going to have an I, but it is solvable. So 56 breaks down to what? 2 square root of 14. Y'all agree? Which one? Break down the 56. 8 and 7. 4 and 2. You were right the first time. 214. 2 radical 14. Okay, and then get x by itself. 8 plus or minus 2 square root of 14. And then we've solved it. Take a little practice on this. We're going to do several. You get that process down. But those steps that are right there, the 1 through 5, 5 steps. Okay? Some of them you get to skip that step. Like this one, we skipped step 2 because we didn't have to divide by anything. Okay? But you're going to have to do at least steps 3, 4, and 5. I know. No question about that. All right, let's look at another one and see if we can do it. Example B. Let's say we had x squared minus 10x plus 4 is equal to negative 2. So it's not equal to 0 this time. That doesn't matter. It doesn't really matter if it's equal to 0 or what it's equal to. The first step was to do what? Yeah, move the constant. Subtract the 4. That's right. So I'm going to subtract 4. It's going to give me negative 6 over there. And I'm leaving that space there because I'm going to add half of b squared. Do I have to divide by anything on this one? No, not on this one. We're going to get to one that we do. Let's see what that does to it. Okay, so try to keep it easier at the beginning. So now I take half of this. What's half of negative 10? Negative 5. So I'm adding negative 5 squared. And if you want to write 25 there, you can. I don't. I think it's important to know that because when you're factoring this side, it's going to factor with that negative 5 in it. Okay? And then this side, that is going to be 25. We're going to have to simplify that. So we got to do order of operations there. So the left side automatically, because we've completed the square, that's what it's called when you do that. It's called completing the square. Because I've completed the square, the factor will always be x plus whatever half of b was. Half of b was negative 5. So x plus negative 5, or you could write it as x minus 5. This is how I'll write it. On the other side, you just got to work this out. What's negative 6 plus 25? 19, isn't it? Once you get here, square roots. Okay, the hard part is up here. This should be the easy part. This is what we just talked about this for a couple of days. So here should be the quicker part. And then get x by itself. What's 5? 5 plus or minus the square root of 19. Okay. Let's do another one. Let's see what we can do here. And we'll see. Let's do this one. 3x squared plus 6x equals negative 15. Trying to get it at different spots and trying to just make sure we can see what to do based on how it starts out. First step was usually move the constant. Is there a constant on the side with the x's? No, so we can skip that step. What's the second step? What's a? 3. It's the number in front of x squared. So we're going to divide everybody by 3. It doesn't matter if it goes into it or not. This one, I picked it because it does go into it nice on this one. So it makes it a little easier for the first one we have to divide by A on. I'm going to leave myself some space to complete the square in, and that gives me the -5 over there. What am I adding to both sides? Half of B, which would be how much? 1. Half of 2 is 1, so I'm adding 1 squared to both sides. And I just keep the habit of putting it in parentheses there so that I know that in that parentheses, that's my kind of my focus area. That's where my half of B is. On the left side, what's this factor as? X plus 1 squared. Good job. What's left on the right side? -4. Good job. Good job. -4. Once we're here, square roots. That's exactly right. Different color. Square root plus or minus square root. That's a negative under the square root. So what's that put into the game? The I stuff. So that's plus or minus what? 2i. Yeah. Square root of 4 is 2. The negative makes it an I. And on this side, we got x plus 1. Let's get x by itself. Yeah, good job. Subtract 1. You got -1 plus or minus 2i. And we're done. A little tougher. Still not too bad. Let's go to the one that's a little more difficult than that one, maybe. It's this one. 3x squared minus 5x minus 8 is equal to 2x minus 3. That one looks hard. Why does it look so hard? Yeah, you got stuff on both sides, and we got some like terms, don't we, on both sides? So what do we want to move where? Move the 8 over there with the 3, right? Or the -3. And then the 2x that's over there with that, it needs to come over here with the -5x. So how do we move that 8? You add it to the 3. How do we move that 2x? Subtract it from both sides. So you got to be careful about that. And I'm perfectly fine with you doing 2 steps at once right there. So these are gonna cancel, and then -3 plus 8 is 5. And on this side, I got 3x squared minus 7x. So again, I'm completing the square to solve this. I'm thinking about those steps. So we got the constant over there on the other side by itself. Got all the x's on one side. What's the next step? Divide. We can't do the half stuff yet. We got to get rid of what's in front of x squared. Remember, that's got to be nothing in front of there. So that step right there is going to be critical in doing this. So I got to divide everything by 3. But 3 doesn't go into either of these. It doesn't matter. You still got to divide by it. All right? So I'm going to divide by 3. And this is where I always kind of find this battle about wanting to convert into decimals. That is never an option. Because if you convert something over 3 into decimals, you can't write enough decimals to get the exact answer. Because 7 over 3 would be 2 1/3, right? That's 2.3 repeating, and that 3 goes on forever. So you can't put enough 3's there for it to be right. So we're going to leave them as fractions. So this side is going to be x squared minus 7/3 x equals 5 over 3. We're just going to leave it as fractions, and that's okay. Now, got rid of the number in front of x squared. Now we do what? Half of b. What's half of negative 7/3? Yeah, negative 7/6. Negative 7/6 squared. Negative 7/6 squared. Okay. Half of b. If you half a fraction, the denominator goes up, doubles. That's the little shorthand way of doing that. If you half a fraction, the denominator doubles. That's the easy way to remember how to do that. Now, left side factors as what? X plus half of b. What was half of b? Negative 7/6. It's okay that it's fractions. I know it makes us nervous and we get a little heebie-jeebie when fractions are in the problem, but it's okay. It's going to work out in our favor at the end. On this side, we got to actually work it out. And I'm not, I just punch that in my calculator and get it to crank it out. Exactly how it's written there. I'd go 5 divided by 3 plus parentheses negative 7 divided by 6 close parentheses squared. Exactly how I've got it written on my paper is how I would type it in there, and just get it to crank it out and make it give you the answer in a fraction. 109/36 is what that should be. If you want to do it without it, go for it. I normally would. If I'm sitting there at the house doing it by myself, I'm not going to get up off the couch and go get a calculator. Not that I sit on the couch and do math problems all day. Well, I'll tell you, I don't. Not anymore anyway. I used to when I was in school. So now, what's next? Square root. Once you get here, it's back to square roots. We don't have. Do we have an I in this one or not? No, because this is not negative over here, so it works out nice. So it's going to be really, hopefully, pretty good. So this goes back to Monday when we were simplifying square roots of fractions. How do you do that? You split it apart and take the square root of each one. The good thing about this one is look at the denominator. It's 36. What's the square root of 36? 6. So I don't have to worry about rationalizing or anything like that on this one because the denominator worked out good for me. But 109, does it break down in? 9 plus 0 plus 1 is 10, not divisible by 3, not divisible by 9, or 6, or 2, or 4. 5 doesn't go into because it ends in a 9 not a 0. Or 5, or 13. Just 13 on here? Those are the weird ones. The prime numbers are the weird ones. I think 109 is prime. Okay, so we just leave it square root of 109 on top. That's okay. Now get x by itself. Plus 7/6. 7/6 plus or minus square root of 109/6. Well, that's an interesting story. I took a class in college about this, and I had a great teacher for it. He's one of my favorite professors. We had a math history class, and he actually told us about the tale. There were these two mathematicians that were like pen pals. I don't know what pen pal is. It's kind of like chatting online, but a lot longer in between messages. And they would challenge each other. They knew each other. They had met at one point, and they decided to start challenging each other. They, to see who's smarter, just like two men would do, something dumb like that. Who's smarter, who's faster, who's stronger, that sort of thing. And they would send each other problems, and they got to sending each other these polynomial problems to solve and come up with methods to solve them. And these guys are pretty smart, a lot smarter than I am. And they found these methods to solve it. And what they would try to do is find that if they sent this problem, he would send, he'd look at it, he'd solve it one way, and the other guy would solve send him the same kind of problem and tell him he couldn't solve it the same way I did. You've got to do it a different way. And so they came up with all these different ways of doing it that worked, and they had to prove that it worked to each other and all that. So it was a pen pal type situation where they're writing letters to each other and sending problems to one another to see who's smarter, and it really advanced mathematics. And the same two guys were the ones that came up with the term imaginary numbers, because they could find answers, but they didn't know where they were because they were trying to graph it on a coordinate plane, and they didn't have a graphic calculator way back then. But they couldn't figure out where it was at because all the other answers showed up. These didn't show up in a certain way. So that's how they came about. It's kind of a weird tale of the world. But anyway. All right. We have reached the end. So this is what we're working on tomorrow is a work day. So if you're going to be out tomorrow for whatever reason, if you're feeling like I don't want to come to schools, it's coming on to you, or you got a doctor's appointment or whatever, I know life happens. So this is what we're going to be working on. And Kayla, I'll give you the notes that we took while you were still out doing the quiz. It's not a big deal. Page 279, 3 through 33. We'll just do odds on that. And then 3, and then do odds on the next page, 3 through 11, 23 through 33 odd, and then all of 35, 36, 37, 38. Okay. And those two sections will be quizzed together on Friday. Today's Wednesday, tomorrow's Thursday, Friday. Yeah, those two will be. That'll keep us from having a quiz on Monday, which is a good thing.